So in order to understand our solar system in its entirety, we need to take a brief survey through the different planets that we have in our solar system. So we're going to start in the center and work our way out. So we're not going to start with a planet, but instead we're going to start with the sun, right? And of course, the sun is a star. It's mostly, as you can see, composed of hydrogen and helium. Right, basically what it's doing, right, is it's fusing hydrogen together to form helium, and that process releases energy, right, and that energy in the form of heat and light, right, which both we need to survive on our planet. 98.8% of the matter in the solar system is inside the sun. So the sun is definitely the biggest thing we have in our solar system. It's pretty hot, right, I would say. And the sun's important. I mean, I hope that's obvious, but the sun is important because its gravity is what holds all of the planets in orbit. And obviously the sun's energy drives some pretty important geologic processes, right? The heat, right, causes evaporation, which causes the whole hydrologic cycle. So that's obviously incredibly important. The uneven heating in the Earth's atmosphere causes the wind and ocean currents, which we also know is important. And something we're going to talk about more when we get to chapter 16 is variations of the sun can actually cause, well, not cause, but trigger or enhance different glacial events. So the sun is obviously important. So, of course, we have 8 planets. Of course, 9 if you want to include Pluto, but Pluto is really just a subplanet. It's not a true planet, and you'll see why as we go through this, why as we've already kind of talked about actually. So we break up our planets into 2 groups, right? Our terrestrial planets and our Jovian planets. Our terrestrial planets are Mercury, Venus, Earth, and Mars. They're all very similar. They are small, dense, rocky. Most of them have plate tectonics. So nothing special there. Our Jovian planets, Jupiter, Saturn, Uranus, and Neptune, are all large and have low density. So we're going to take a brief survey through. Please don't try to write down or take notes on every single thing, just the important identifying characteristics. So we'll start closest to the sun, which is Mercury. Mercury is the smallest of the terrestrial planets. Because it's closest to the sun, it has a very short year. 1 year is only 88 days. Also, because it's closest to the sun, it has more craters than any other planet because it's receiving that full force right there from the sun. We do see large fracture zones, which tell us that there either was or still is plate tectonics on that planet. There is an atmosphere. It's got helium, oxygen, potassium, and hydrogen. It does have a weak magnetic field, which is telling us that it probably has an iron core and a liquid rotating around it. And it's just too close to the sun to have any moons. Moving out, we have Venus. Venus is generally considered Earth's twin because it's the same in size, mass, and volume. However, it has no liquid water, right, that we know of. What's interesting about Venus is when you take a look at this picture, you're not actually looking at the surface of Venus, you're looking at the atmosphere, which it has an insanely high atmospheric pressure, and the atmosphere is almost 100% carbon dioxide. Because there's so much carbon dioxide in the atmosphere, that's basically what we're looking at here, right? It's just all that carbon dioxide. All that carbon dioxide causes sulfuric acid to be in the atmosphere, so not a nice rainy day ever on Venus, sulfuric acid instead. And because of that carbon dioxide, we have a major greenhouse effect. Remember, the greenhouse effect essentially is that the carbon dioxide in the atmosphere acts like a blanket. The sun's rays are allowed to come in, but they can't escape back out into outer space. So it traps all that heat. So the surface of Venus is about 470 degrees Celsius, which is pretty insane, right? Pretty intense there. It has a very long day. Venus, early on in its history, collided with a large object, which caused its rotation to spin in an opposite direction and slower, right, than all the other planets. So one day on Venus is 243 Earth days. So if you need more time in your day, that is where you should go. It definitely has volcanoes and craters, so there is definitely some semblance, most likely, of plate tectonics on this planet. Not going to talk about Earth too much because that's the whole semester, but we're actually, pretty average. We're not a very large planet, but we're gonna go through more of the Earth all semester. Then we have Mars, which Mars is pretty unique. It has polar ice caps, as you can see, right, in this picture here. The ice caps are made up of carbon dioxide ice. We do see that it has seasons, right? In the winter, those ice caps get bigger. In the summer, the ice caps get smaller. It does have a rusty orange color because there's a lot of iron in those rocks, and that iron's just oxidizing or rusting. So Mars is pretty much a giant rust bucket. Mars is only about half the size of Earth and about 10% of the mass, so it's pretty small compared to Earth. However, what's really interesting about it to me is that we see some features that are very reminiscent of what we see on our planet. For example, down here, right, as I trace this out, we have a very large volcano that you can see in this picture. Mars is a geologically dead planet. Plate tectonics has stopped on that planet. Mars has solidified all the way through. So we're no longer generating magma underneath the surface. So this is a volcano that was once active but is no longer active. However, if we take a look at some of these other features, you see these long features over here. Those are big dunes. So we definitely have some wind-blown sediment here. And if we take a look at these other features around, this should remind you of what we see here in Louisiana at the end of the Mississippi River Delta. Because basically what we have here is river channels, right? This is river deposits. So we know Mars actually once had a lot of free-flowing water. Mars does have frozen water there right below the surface. We know they actually have that cool little rover there. So Mars actually has a pretty interesting geological history. Moving out, now we're done with our terrestrial planets. We'll move into the Jovian planets. So the largest planet we have is Jupiter. Jupiter is pretty big. It would take 11 Earths to stretch all the way across to make one of Jupiter. So it's pretty big. It's definitely low density because, again, it's gaseous. It has a very quick day. One day on Jupiter is only 10 Earth hours. And because of that fast rotation, that's why we get the banding of the gases in the atmosphere, right, that you can see in that picture. Of course, it's got the Great Red Spot, which is just a big cyclonic storm. Now, in my opinion, what's even more interesting about Jupiter is not Jupiter itself, but its moons. Its 4 largest moons are actually pretty interesting. Its largest moon is Io. Io is neat because it has the largest volcanic eruptions in the solar system. And it's not just, boring old liquid rock that comes out of there. It's actually liquid sulfur. So as you can imagine, I'm sure that wouldn't smell amazing. The other moons, Europa, Ganymede, and Callisto are neat because they all have liquid water beneath an icy surface. So if we want to take a place to look and see if there's any other living organisms on our planet or to see evolution in action, that should definitely be where we should take a look. Then we have Saturn, which is the second largest planet, easily identifiable because of the large rings that it has. What's kind of cool about Saturn is that it has such a low density that if you could find a bathtub big enough, it would float. It has a density lower than water. Then we have our next planet, and we have Uranus. And Uranus is only about 4 times larger than Earth, so it's not a very big planet. I do want you to notice that it's blue, and it's blue because it has quite a bit of methane in its atmosphere, so that's what gives it that blue color. And its axis of rotation is tipped on the side, again telling us that early on in its history, it collided with a large object that caused its plane of rotation to tip. And then finally we have Neptune. Neptune is pretty similar to Uranus. Blue again because of all that methane, very low density. What's neat about it is it also has a cyclonic storm, just like Jupiter. So there was our brief survey of the planets.